Let me start off with something really, 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 really cool.
Really
You know,
cool.
you know Neuropixels, right?
Oh yes, those are really cool.
Neuropixels are cool.
Yes.
For anyone who doesn't know, Neuropixels are basically circuit boards, like silicon boards with little recording sites, electrical conductive sites. You shank them into a brain, and then you record the electrical activity of all the cells or the neurons around your probes. And you can record from. We were collaborating with a lab in the USA. Um, they could record from 4,096 sites. It doesn't directly correspond to 4,096 neurons, but you get a couple of thousand neurons out of that. It is okay, a couple of hundred.
4,000? Is that one neuropixel? That's
Oh,
more,
we
right?
get a follow. No, that is not one. That is not one. That's four probes, but
Yeah, that's four probes. I thought there were like a couple of hundreds on one probe.
1,024 per
Oh,
probe. Yes.
2024. Because the probes that like these recordings, we have to tell the people maybe like the first of these recordings are pretty good, and we're done with like 4 electrodes, right? And then you can, around these 4 electrodes, you can locate some neurons and you can know which is which, and you can spike sort a bit usually. And then people started like increasing the number of kind of recording points on these probes, and like I have seen them with 32 when that was the most fancy thing. And now
32.
yeah. And now we have, so this is the 1024. This is impressive. Like if like in my own, no, like that
No,
was
that's
my
that's already
master's.
2 years ago. I'm sure they've gone up more. Anyway,
No,
the reason I'm bringing it
we're
up
probably working
is
on it.
well, I mean, you have the constraint. Like you have basically every site is one wire, and you have to get that wire up
Yeah,
out of your probe. So the more sites you have, at some point you can't make the wires any smaller, and then
there
you know,
should be a limit.
yeah,
Yeah,
there's an upper limit to how many sites you can record.
but
Anyway, the reason I'm bringing it up now is let me see if this works. Bam! Large scale neural recordings with single cell resolution in human cortex using high density neuropixels
it's
probe.
like the dream that you have the neural pixel and then you can also put it into the human cortex.
They did that. That's what they did.
I know, it's a dream, but it's real.
Yeah, no, it's not a dream. It's real. They did it. So let me read the abstract. So recent advances in multi-electrode array technology have made it possible to monitor large neuronal ensembles at cellular resolution, as we said. In
Yes.
humans, however, current approaches either restrict recordings to only a few neurons per penetrating electrode or combine the signals of thousands of neurons in a local field potential, which is the other thing we do. Here we describe a new probe variant and set of techniques which enable simultaneous recording from over 200 well-isolated cortical single units. So that's ostensibly 200 neurons. In human participants doing interoperative neurosurgical procedures using silicon neuropixel probes. I don't know how they got permission to do this. I don't know who these patients are who said, yeah, no, sure, you can put a probe in my brain.
With-
You would?
But if no, no, I wouldn't just go to surgery to have a probe put in my brain. But usually these are surgeries with people that get like maybe not implants, but usually when some part of the brain is lesioned, right, or even something is implanted, you open up the skull and you take out part of the brain because there's something seriously wrong, like there are debilitating what is it called, epilepsy attacks or something, or like
It's actually quite
very,
common for Parkinson's disease.
yeah, that you
Deep
get
brain
the deep
stimulation.
brain stimulation. Yeah, also
Mhm.
for depression. But then you only, I don't know how far you open up the brain then, and if it is safe to put a silicone probe in. But in epilepsy, usually part of the brain is lesioned. So then even people do slice EVIS on the part that is lesioned, right?
It's
So
true.
this is,
A colleague of mine is now working in Berlin doing just that. And they don't
yeah.
know in advance when they're going to get tissue. So
Oh.
they're going to be called in the middle of the night like, hey, we just operated on a patient. We just got the brain part out. Here it is. Good luck. And then they
And
can record for about 36 hours or so.
yeah, they
And
can
they
for long.
do it in one go. Like they don't stop. It's
But
insane.
I think they
People
have
doing the
shifts
research.
and like multiple rigs with multiple people running
Yeah,
on
but
this,
like
right?
the
Yeah.
tissue is so rare, so precious that
Yeah.
they keep going until the tissue dies.
Yeah. Yeah, this is amazing. So this happens. So if I would like get any surgery like that, I would of course say yes if a researcher was like, I have this Neuropixel probe. Maybe we can try that in your brain. Like, of course you say yes, no, or not? I don't know.
I mean, it's
Uh,
unproven experimental technology. I would be a little bit
Fine,
hesitant,
it's
but
fine.
that's me. That's me. Anyway, let me show you the figure one. So here in A, we see what those probes look like. Well, you hand for scale. These things are tiny. You can see all the
Very
sites are marked here. And yeah, that goes into human patients. Bop, straight down. Then they did an MRI, I guess. It's in the prefrontal cortex. Is it?
how they put it in. Why would they put it in the prefrontal? That's a weird position.
At least I'm seeing something like DPFC here.
I'm
Or
checking the image.
DLPFC, so dorsolateral prefrontal cortex, presumably.
Yes,
Yeah. I mean, again, I don't know why or how.
because that's a very uncharacteristic brain area to do deep brain stimulation or to lesion. That's weird.
Yeah. So,
Maybe it's
but
a tumor
I've
then
dropped
or
a link
something.
in the chat. This is now on bioRxiv, which is a preprint server, so it hasn't been peer reviewed yet. But this is really fresh, and yeah, it reminds me a little bit of the Elon Musk's Neuralink thing. You remember?
Mm.
Basically,
Yeah,
the
yeah,
promise was Elon Musk was gonna do well this in humans, and then he said,
yeah.
one day you'll be able to get this implant, and then you can listen to music without having to have an earplug in your ear. Like, okay, you know what? Between you and me, if I have to choose between brain surgery or putting something in my ear, I will put something in my ear. I'm okay with
Yeah,
things in my ear. I don't want brain
yeah,
surgery.
yeah. Also, that
But
would be like the brain already made something to listen to music. Like the biology made something. It's an
it's
ear. So
pretty good.
maybe
It,
we
it
should just use it. I think it's pretty okay. Yeah.
but of course, this is one way. This goes the other way. Like, so this records from your brain. It doesn't stimulate it.
No,
Um,
thank goodness.
but I think Musk also mentioned that somewhere, like, we could have a car that would um, interpret your brain waves and steer you to where you want to go. You just have to think about where you want to go, and your car will go there. Which is theoretically possible, but again,
Yeah.
I have hands. I can type in the destination. I can even say it out loud, like via voice recognition.
Well, yeah, the destination wouldn't be,
Like,
but
drive
some,
me to the supermarket. I
I
can
don't
say
know,
that. I don't need to have a brain implant to do that.
but
But Cici,
something.
Yoshi here over here is signing up for it apparently.
Nah, no, 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 no. But it might be interesting to like to steer some things directly with your brain, but not your car. No, that wouldn't be
How
good.
about your hands?
Yeah, I can already do that. Don't need implants. Maybe it is more useful once you cannot use your hands very well anymore, or something like, or like even if this would be like a very advanced technique, because now, of course, you use whatever you have if you uh, have paraplegic patients, right? You use whatever brain interface or blinking with the eyes, like whatever you can get. But if we advance this more, like Elon Musk wants, then you could also, if you have like some pain in the hands and you cannot use the hands for some reason, you could use this implant to like, if it's very advanced and easy to implant and safe, it would have
We will
more.
see in the future. Let's move
Yeah,
on.
but I think it's a good development, right? We should think about this because it can be useful in some cases.